So good day everyone. So for today's video, we're going to explain our final project for this semester, which is about predictive analytics case analysis, which we will be focusing on the churn analysis. So before we start with the discussion, I would like to present my members. So I am Rose Anjoy Dimamay together with Rainier Navarro and Ruben Ray Bragas. Next slide, please. Next. So now we're going to explain um, each data that we have gathered. So here is the data pre-processing. So in this section, wherein the data will be loaded first and then pre-processed before being used later for the model training. The important libraries for this section would be NumPy, Pandas, and Matplotlib lib for visualization. Next slide, please. So as you can see here in the data simple statistics, so the data seems to have null values. So therefore, we will be filing them up manually by its mean value. So after which, we will then check the nulls yet again using info method. Next slide. So here we can see quick data null handling. So in line 8, the next few columns will be focusing in visualizing and finding out the differences between those who churned and those who didn't. So the plots will visually show us the difference. So in line 38, the revenue seems to only have a small difference for both the churned ones and the ones that is not churned, with the churned ones having a higher revenue by an average of 60 wheels, the non-churned ones having an average of 50. Next slide. So here's we can see the data simple biology. So the revenue seems to only have a small difference for both the churned ones and the ones that is not churned, with the churned ones having a higher revenue by an average of 60 wheels, the non-churned ones having an average of 50.
Okay, we will be explain the data exploration. Now we will be showing some examples of data exploration. In this figure, the drop the drop and blocks call seems to be more with the non-churn customers than the ones that are churned as evident in the pie graph. And in this slide, there seems to be a higher chance of the voice called being dropped with the churn customers than the ones that are not. As you can see in the pie chart, uh, in this slide, the drop busy by group, churn or not. This is a simply a manual checking of the differences of the churn customers have with the non-churn ones. And in this figure, the data shows the main difference of the churn customers and the not churn customers with the higher rate of drop calls and out calls coming from the not churn customers and the lower ones with the churn customers. The income seems to also be a higher with the churn ones than the non-churn ones. It simply seems that the positively rated attributes are more inclined with the churn customers than the non-churn ones. And the next presenter is Raagas.
So now we will showing the prediction models and we'll explain some of the example. Next slide. The logistic regression is a type of classification regression prediction model that is the best with determining binary classes. In this case, it seems to be the best model as it offers a high F1 score, precision, and recall. This model also has a higher coefficient of determining as evident by the R2 score. Next slide. KNN classifier is a type of prediction model that grades with adjustment if such data as binary or if it contains multiple classes. This model seems to be the third best model for this data as it seems to be have an above decent F1 score with its very decent precision score and recall. The R2 score seems to be low but not negative, which suggests that 30% of prediction explains most of the model's accuracy. This prediction model is a type of regression algorithm that is best used for analyzing multiple variables for dataset with high dimensionality, but Scalar offers a more classification-sided type of algorithm. As evident with the scores, this model seems to be the second most useful prediction model for the dataset with the high F1 score 90 and decent enough precision and recall, which means that such true prediction were correctly predicted. The R2 score seems to also have a decent score, which explains 56% of the overall prediction. Next slide. The SVM or support vector machine is a type of linear classification prediction model that is best with binary classification datasets. This seems to be the close second model for the first one, which is the logistic regression with an F1 score of 92% of a high enough prediction score and a higher precision and recall. It also has a high R2 score. Next slide. Naive-Bayes classification is a type of classification which heavily relies on the naive-Bayes probability. It is the fourth most useful model as it scores significantly lower than the rest of the used model, which gained an F1 score of 85 and above and a higher precision and recall than 75. This is pretty evident with the R2 score, which is lower than any other model used in this research.
So so to conclude our discussion, so the churning seems to affect the revenue very little, as could be seen with the data exploration done, with only having difference of 1.06 higher for churned ones and lower for the not churned ones. There also seems to be higher drop voice calls and the drop black calls in not churned ones as opposed to the churned customers. There also seems to be higher chances of the customer having professions of professor and etc. for the churned ones than the non-churned ones. Since the data set seems to have a binary type of class, it is very evident to see that the models that are focused on binary and are not great with multi-class predictions having a better accuracy score and better prediction predicted than the ones who are great with multi-class problems, such as model SVM and logistic regression have a high accuracy, 90 above, and higher recall, and the precision than any other model, which suggests that they are great with predicting the true values than any other prediction model explored above. Since the SVM has the best overall statistical model performance, this will be the final model that will be used to show the first 20 predictions of the model versus the actual values. Next, please. So that is the end of our discussion. Thank you for listening.